Hi, we're going to continue with what we've learned in Desmos and see if we can apply these three formulas, the vertex form, the root form, and the standard form of a quadratic, and see if we can apply these to a picture that has a real-life example of what a quadratic could look like. Now, I've downloaded this file from the TI Inspire website. And here it shows a person shooting a basketball, and you can engage your students by asking them, okay, what does this look like? And haven't seen lines and haven't seen quadratics. Hopefully they'll say quadratics, and then that leads into other questions that you can ask them, such as which way does it open? Is there a vertex? Is it a max or a minimum? Are there roots? And other questions that can be applied from this. As it is right now, there's not a whole lot we can do to this unless we add some axes, like an x-axis or a y-axis, which has been done here. So, I think what else would be very beneficial is if we were to put grid lines on this so that a student could see this on a coordinate plane. And the way we do that, we hit Menu, View, go down to Grids, and put a line grid. Now once we do that, we can see now that we have our XY graph and also all the lines that go with it. And we can also see that, well, this appears like he's shooting it from here, although it's not quite exactly on the y-axis. We kind of get a very close depiction of what this picture is. And then you can also see other very important parts or points to this. So what we're going to do now is we're going to attempt to write an equation for this. And here it is given to us in function notation. So if students want to start off and write x squared and hit enter, they can see that, well, it is quadratic, but it's facing the wrong direction. And using what they've learned previously, they can try to apply this. Now all I did was double click on this expression right here, and it took me to this so that I can manipulate it. Well, let me try putting a negative sign in there and hit enter. Well, you can see that it's now shifted down to the bottom, which is not quite what we want. And hopefully they now see that, hey, you know what, I need to apply some transformations. Maybe this point needs to be slid over and brought up some. Okay, so hopefully they now kind of remember some of the forms of the formulas that they have. And it wouldn't be a bad idea to have those available to them so they can look at it. Okay, now this picture looks like it got shifted to the right 7 units. So we'll write it in the correct form. And then it looks like it got translated up 8 units. And I'm doing by looking at the origin and counting over 1, 2, 3, 4, 5, 6, 7. And then going up 1, 2, 3, 4, 5, 6, 7, 8. And then hit an enter. Okay, now it looks like our vertex is in the right spot, but it's not quite as wide as we need it to be. So let's do some more adjusting. So I'm going to double click on it. That allows me to now move over here. And some students are going to say, let me plug in a 4 because 4 is a bigger number. Let me see how that affects the graph. Well, it's actually stretched it and quite the opposite of what we want. So let me click on this. At the beginning I had negative, which represent negative 1. So let me try something like negative 1/3. See what that does. Okay, now we're going in the right direction now. Let's do with a few more adjustments. I believe the students could get to the point where they can now put in something like negative 1/10, hit enter, and see that, well, let me now move this out of the way so we can see that the path of this basketball going into the goal is very similar to this linear regression. Now, we didn't calculate it with the regression. we actually plugged in the numbers to the vertex form to get what we saw was pretty close. Now, in seeing that, we can also see other points that we didn't or weren't able to see earlier, such as where it crosses the x-axis, which we know as roots. So I'm going to move this over to the side, and now I'm going to attempt to put in the next form, which is root form. Okay, so all I have to do is hit tab. A new function bar will come up here. Now the width of this parabola is still -1/10, so I'll type that in here. I'll say -1 divided by 10. And then if I remember my formula, that's x minus r1. Now r1 is at -2, but when I minus that negative, it becomes +2. And then I plug in x minus, and this point over here appears to be at 16. So I'll say x minus 16. And then I'll hit enter. And you can see that it now put that red line on top of the blue one. Now there's a little, once you click on it, you can see that it's directly on top of it. I know it looks like there's some spots in here, and that might be some programming, but it's actually it's the same thing. So now what we're going to do is try to get our third equation, which is in, well, it's standard form. Now, standard form, I would actually tell them, instead of trying to plug in an A, B, and C and adjusting a lot, I would actually tell them to do a little paper pencil work and take this one, this form, multiply the two binomials, and then multiply everything by -1/10, and then plug it into what they've got. So here I'll type it in, -1/10, parentheses, actually it's just x squared, plus 14/10x. Let me make sure I put the correct, that's plus, and then plus 32/10, and hit enter. And now I have shown that I've used 3 different forms. That gives me the same quadratic that represents this real life situation.